Hello, everybody. We're going to have a short little video here to teach you how to do single replacement reactions, and we're going to be talking about the activity series. So if you could please get your green sheet out and open to page 24 and click continue once you are ready. There's nothing to write down for this slide, but there will be for the next one. So when we're talking about the reactivity of metals, this is talking about like how easily or how fast an element will form new compounds in a reaction. If an element is very active or reactive, it's going to often be found as a compound. So something like chloride is almost always found in a compound. We don't often see it as its normal self, chlorine, that often in nature. Now, things that are unreactive, stuff like silver and gold, are often found just as elements and not often found in compounds. Alrighty, so at the top of page 24, there's a little blank that says activity series, the ranking. So ranking is your fill in the blank in metal activity or reactivity. So this list that you see here is going to tell you how reactive certain things are. All right, so there's also a blank in the arrow, so make sure you write that in. The reactivity of these elements increase as you get higher on the table. So lithium would be our most reactive, and gold would be our least reactive. Alrighty. So we can use this list, right, to compare two metals and decide which one is going to end up in the compound in a single replacement reaction. So here's some examples. Before we combine copper and silver nitrate, we have a copper wire in a what looks like a clear solution. Right, and after, right, the copper steals the nitrate and turns the solution blue, the silver is kicked out of the solution and deposits on top of the wire. So these crystals that you see here are actually pieces of silver, right? And the bluishness that you see in the solution belongs to the copper, right? So they have switched places in that reaction. And they have done that because copper is more reactive than silver, right? Another example is silver tarnish. So as you have some old silver and it ages over time, it reacts with the sulfur in the air and you start to get this rainbow-like color or even some looks like rust. We call that tarnish. So that's not dirt that's on there. That's actually a chemical reaction that's happened over a long period of time. If you have any questions about this stuff, Mr. Arrow is a great person to ask. He has been a coin collector for quite some time. Alrighty, so right, if we're going to look here, right, let's just answer some of these questions. So, will tin react with sodium sulfide? So, tin is a metal. We're going to compare that with Na, which is sodium. So, if we look on our activity series, right, we see tin is down here. And where is sodium? Sodium's up here. So will there be a reaction? There will not, because sodium is higher than tin. Sodium is going to be the one that ends up in the compound. Right? A reaction will only occur if that lone element, in this case tin, has a higher reactivity than the metal in the compound. So we would only see this combination react together if tin was higher or above sodium on our list. Right? And the more reactive metals end up in the compound. So whatever's higher on that list should be the one that's paired with another element. All right, so let's do a couple practice questions. Will cobalt react with zinc chloride? Will lead react with silver nitrate? And will barium react with iron chloride? And you can use this to help.